Welcome back. Let's try number 2. Remember that we are doing the first derivative test here, so we need to find critical numbers and then test critical numbers to find increasing, decreasing, and extrema. So to find our critical numbers, we find y prime first. So I take the derivative of this is going to be 1 minus 2 cosine of x. And then my critical numbers are where it is 0 or undefined. Now, real quick on undefined, this is a cosine, so that's not going to have any undefined parts. We'll have some zeros. So let's do set it equal to 0 and solve. Okay, so I have cosine of x equals 1/2. And I do have a domain restriction here from 0 to 2 pi. So I want all the places where the x value is going to be 1/2 from 0 to 2 pi. So that looks like it's going to be pi thirds and 5 pi thirds. Okay, now I need to test these critical numbers. So I'm going to put these critical numbers right here. Pi thirds, 5 pi thirds, and keep in mind that I have a domain restriction of 0 to 2 pi on this number line. And now I'm going to plug them in to see what I get. And by plug them in, I mean, do my sign line. So I'm going to start with a number between 0 and pi thirds. So let's say pi 6. And plug it into my derivative. So you can type that into your calculator if you want, but the most important thing is that it is negative, which means it's going to be decreasing. Now let's pick a number between pi thirds and 5 pi thirds. Let's say pi. Which again, you can type that in if you want. Most important thing is that's going to be a positive number. Oops. Positive, so increasing. And then we need to plug in one more number into f prime. So let's say 11 pi 6. So we're plugging it into our derivative and typing that in to find that that's a negative. So that means the original will be decreasing because that's a negative. So now we've got our increasing and our decreasing. It's going to be increasing from pi thirds to 5 pi thirds. Use brackets like we talked about in the first video. It's going to be decreasing from, 0 to pi thirds. The reason that is a parentheses is because that's how it's done in the problem. And decreasing from 5 pi thirds to 2 pi. Once again, that's parentheses because that's how the domain is listed. If these were in brackets, then the 0 and 2 pi would also be in brackets. And now we need to talk about maximums and minimums. So it looks like I'm going to have a minimum there and a maximum there. So I've got a maximum at 5 pi thirds, comma something, don't know that one yet, and a minimum at pi thirds, comma something. And remember, to get these ones, you plug those numbers into the original, into f. Not f prime. So plug pi thirds, or let's start with 5 pi thirds. Plug 5 pi thirds into f. And I'm not even going to simplify this time because why should I if I don't need to, right? Excuse me. So I've got 5 pi thirds minus 2 sine of 5 pi thirds. Just plugging it into the original. And pi thirds minus 2 sine of pi thirds. And there we go. So that's all of our answers for number 2. Okay, with that, I would like you to start trying number 3 on your own. So find your critical numbers, find the derivative, set it equal to 0, find where it's undefined, test your critical numbers, and see if you can find the increasing and decreasing all by yourself. And then you can come back and check to see if you got it right. Also, sorry, really quickly, I forgot about this part. For the derivative of this, you can do quotient rule if you want, but I just wanted to remind you of a little trick. Separating the denominator like that. So then you get 1/3 x cubed plus, let's see, this would just end up being x to the -1. And then it's a lot easier to take the derivative of that than do quotient rule on that. So if you want to do it that way, you're welcome to. If you do quotient rule, you should get the same thing. You'll just have a little more simplifying to do. Okay, now go. Welcome back. Let's see how you did. So I'm going to start. I took my derivative of this, which gave me x squared minus x to the -2, which is x squared minus 1 over x squared, which, when I find common denominators of x squared, gives me x to the 4th minus 1 all over x squared. And that's what you should have gotten if you did quotient rule as well and simplified it out. So we're left with that. Now we wanted to find our critical numbers. First, where it equals 0, so I set that equal to 0, started solving it. X to the 4th minus 1 is x squared minus 1, x squared plus 1. X squared minus 1 is x minus 1, x plus 1. So I'm basically just factoring it all out and then setting them all equal to 0 and solving. When I did x squared plus 1 equals 0 and solved, I got an imaginary answer, so that one's not going to work. But then I got plus and minus 1 for those. Now for undefined, set your denominator equal to 0, solve it, got x equals 0, which I do know is an asymptote because you can see that in the original. If it's an asymptote in the original, it's going to still be an asymptote in the derivative. X equals 0 gives me an asymptote right there in the original. So that's why right here I kind of did these dotted lines to show that 0 is an asymptote. So then I did my sign line. I just started plugging things into the derivative to get my signs. I got positive, negative, negative, positive. So this is increasing. This is decreasing to the asymptote. This is also decreasing to the asymptote and then increasing. So I wrote those down there. And then I have a max here because it goes from increasing to decreasing, and then a min here from decreasing to increasing. And so I had a max at -1, a min at +1, and I plugged -1 and +1 into the original to get those points. So that should be all of it. In the next video, we'll try the last two. I know these problems take a long time. They're kind of time consuming, I think. It's not really hard, it's just time consuming. A lot of little things to do. But you got this. I know you do.